Alright, so in this video, I'm on page 203 in the binder. And if you have like different colored pencils or pens, this is a good section to use those on. Because what we're going to do is something called solving a system of inequalities. So in the last video, we graphed single inequalities, where we graphed something like y is greater than 2x minus 5, and did the slope and the y-intercept, drew a dashed line, and shaded by testing a point and figuring out which side to shade on. Well, to make it a system, we just need two inequalities. So up at the top of the page here, we've got this example, and I was already talking about y is greater than 2x minus 5. That's this dotted line here. If you test 0, 0, you'll find out that you shade above that line. And then y is greater than or equal to negative 3/4 x plus 3. That's this one. Negative slope, y-intercept of 3. It's a solid line because it's or equal to. And then if you test 0, 0, that's false, so you end up shading this side. Well, to find the solution for both of these, it's the section that was shaded for both lines. And so since we shaded above the dotted line over here and above the solid line like this, the section that got shaded for both is this kind of top triangle here. So every point in this top triangle section will be a solution to this system. It'll make the top inequality true because it's above the dotted line, and it'll make the bottom inequality true because it's above the solid line. So it has to end up it ends up being all the points in this shaded section. Okay. So let's try a few together here. So if we look at example 1, problem A, we're going to just graph each of those separately. So the first one is, I'm going to do it in red, y is less than x plus 3, so I go to plus 3 for my y-intercept, and then my slope it's just 1x plus 3, so my slope is positive 1, so I'll go up 1, right 1, up 1, right 1, down 1, back 1, like that. And then this becomes a dotted line because it's y is less than, not or equal to. So I draw a dotted line. And then I have to test 0, 0. So for the red one, we test 0, 0. And I get 0 is less than 3. That's true. So this is the right spot. So for the red line, now watch what I do here. I'm not going to shade it all crazy like I used to. I'm going to draw these like perpendicular lines to the dotted line. Okay? Because what I want to do is see where my shadings overlap. So my second equation, or inequality, I'll graph it in blue. Y is less than negative x plus 2. Y-intercept is 2. And now this time my slope is negative 1. So I go down 1, right 1, down 1, right 1, up 1, back 1. This one's also a dashed line. So let's do this. And when you're doing these shading problems, you want to make your lines as long as possible so you get to shade as well throughout the whole graph, basically. You don't want the shading to be just a little teeny bit. Okay, so again, I'm going to test this time 0, 0. Again, as long as it's not on the line, you can test it. So we test 0, 0, and we get 0 is less than 2. That's also true. So I'm going to shade for the blue line below the blue line because that point worked. Okay. Notice when you do this, you end up with you end up with these 4 sections: top, right, bottom, and left. Okay, the section that I shaded twice is the bottom. So what we do to finalize this is to really darken in and shade in that section completely, like that. Okay, so every point in that section is a solution to this system. So when it says list one solution, I can pick any point that's in there, including like 0, 0 was in that section. So there's one. I could pick maybe, like if I go right 2 down, or right 1 down 3, that would be 1, negative 3 would be another solution, etc. Okay, let's try B. So for B, the top equation needs to be solved for y, so I'll divide everything by 4. I get y is less than 2x minus 2. 2x minus 2. right? And then for the bottom equation, it's already solved. So let's do this. Y is less than 2x minus 2. Go to minus 2. Positive 2 is my slope. And it's less than, so this will be dashed. Alright, if you accidentally make a mistake and do it solid, or you want to make sure you're clear, you can just write the word dashed and point to the line to indicate that that's a dashed or a dotted line. And then y is less than or equal to x minus 1. So negative 1, and then the slope is positive 1. So I go like that. And this one's solid. Okay, I need to do my test points, excuse me. So for the top equation, which was red, I'll test 0, 0. And when I do that, I get 0 is less than 2 times 0 is 0, so negative 2. That's false. So when I tested 0, 0, that was the wrong side of the line. So my red line, I'm going to shade away from the point 0, 0. Okay. Notice I ignore the blue line there. Then for my blue line, I'll test 0, 0 also. And what do I get? I get 0 is less than negative 1, or less than or equal to negative 1. That's also false. So once again, 0, 0 is the wrong line, so I'm going to shade away from it. So now I need to be using the blue line as my starting point and ignore the red one. Okay, so the section I shaded twice is the one that's below both the red and the blue lines, which ends up, if you look at it closely, it's this section here. Okay, so everything there, I'm going to darken in. Okay, one solution there would be, let's pick a point way out here. Let's go with that point, which is 1, 2, 3, 4, 5, negative 2. Oh, wait, I didn't answer the question that's actually there. List an ordered pair that is a solution to only one of the inequalities. Well, that would be one of the sections that's either only shaded blue or only shaded red. So what if I pick this point there? That's only shaded red, so that's the point 5, comma 5. Okay. All right. Finally, part C. In part C, I've got x is greater than negative 3. That's a vertical line at negative 3. So I'll do that one in red. Okay, and I'll test it right away. Test 0, 0. I get 0 is bigger than negative 3, which is true. So the 0, 0 works, so I'm going to shade on the side towards 0, 0. Bottom equation there, let's solve it real quick for y. So I get negative y is less than or equal to negative 2/3 x plus 2. I subtracted 2/3 x to the right side, and I have to divide by negative 1, which means my sign flips, and I get positive 2/3 x minus 2. So I go to minus 2, and go up 2 over 3 to the right, down 2 back 3, down 2 back 3. So this one's solid. Okay, and then in green I'll test, what am I going to test here? 0, 0. And when I do that, we're testing 0, 0, we get 0 is greater than or equal to negative 2, which is true. Okay, so I'm going to shade towards 0, 0 on the green line. Okay, and now I can see that I get an overlapping shading in this section here. So I darken it in, and those are my solutions. Okay, then finally this question asks, is negative 3 comma negative 4 a solution? Let's see, I go to find that point, I'm going to draw it in blue here. Negative 3, negative 4. Is that point a solution? Well, it's on the solid green line, so that's good, but it's on the dashed red line. The dashed means like the just greater than. So 3 is not greater than, or negative 3 is not greater than negative 3. So the answer is no, that is not a solution. It would have to be a solid line for it to be a solution. Okay. There's a few more examples on the back page. If you want to try any of those out, I'll put the solutions up on the video in just a few seconds here, but otherwise that's it for this video. Thanks for watching. Alright, you can check those answers at the top here on the next page. Alright, thanks again for watching.